Welcome to What's New in OpenShift 4.14. My name is Daniel Messer. I'm part of the OpenShift product management team. And today I'm joined by over 30 of my OpenShift VM colleagues today to walk you through what we've been working on the last couple of months that culminates in this new OpenShift 4.14 release. As you can imagine, with a large and comprehensive platform like OpenShift, there's a lot of innovation and features that goes into a release like this. So we'll start with a high-level overview and then go over the spotlight section and then go into the details of the various areas that we've improved. So at a high level, you can see three broad areas that we invested in OpenShift 4.14. And unsurprisingly, it starts with security, right? So we are enabling customers who are running OpenShift on Microsoft Azure to more securely connect the cluster and its core operators to the Azure APIs with something that's called Azure Managed Identity. This is more secure communication based on short-lived authentication tokens versus the more long-lived credentials you usually see. But we're also looking at tenants who are not only allowed to share configuration data in Kubernetes config maps, but also confidential credentials and Kubernetes secrets across more than one namespace now with the so-called shared resource operator, which is going generally available in 4.14 as well. And on top of that, we are making the experience to store secrets actually securely in OpenShift more pluggable with the release of the Pure Secrets CSI driver, which is a tech preview in 4.14, which allows to plug third-party secret storage solutions to OpenShift. The second big area that you see us investing is optimizing the cost and the resources that are needed to run a fleet of OpenShift clusters. And hosted control planes is our technology to do that. And what you basically see is a control plane that's running in a very condensed, containerized format, which not only cuts down the resources you would typically need to run a control plane for OpenShift by over 60%, you also literally cut the deployment time in half by this. So we are very excited to announce that hosted control plane is going generally available on bare metal nodes, as well as in conjunction with OpenShift virtualization in 4.14. And we are also looking to expand this experience to heterogeneous clusters. So there are fleets of worker nodes that don't necessarily all have the same CPU type. And we're starting with a tech preview of the combination of having an x86 control plane in containerized hosted control plane fashion in conjunction with worker nodes based on IBM power systems. And as you can imagine, with every release in OpenShift, there is a lot of work and enhancement that goes into the very core of the platform to make it more configurable, more adaptable, and more flexible. So we are starting to expand the support timeframe for non-x86 architectures to align with the 24 months we had for x86. We are also seeing a huge revamp in the internals of our OVN-based networking layer to essentially improve the operational latency as well as improve performance, especially at scale. For VMware customers, we are making it easier to automate the transition to CSI. And for partners, we are generally allowing a better experience when it comes to integration at the infrastructure level that runs the cluster by supporting a new provider type in our OpenShift installer called external. These are just some of the highlights that we are going to hear more about in the next 90 minutes. But obviously, all of that is based on a very strong foundation of Kubernetes. So I'm happy to hand over to Karina now to walk us through what's new in Kubernetes 1.27.
Thank you, Daniel. Now, this release of OpenShift 4.14, as Daniel mentioned, is based on Kubernetes 1.27 and Cryo 1.27. Now, Cryo has reached graduation status in the CNCF. That's the Cloud Native Computing Foundation. And it highlights just and celebrates really all the hard work that the project maintainers and the project contributors have put into building a mature, stable cloud native container runtime. So really congratulations to the Cryo team. All right, so upstream, there were 60 enhancements in this Kubernetes release, 13 of which graduated to stable. And a few notable enhancements include the work being done in the scheduler to optimize the pod scheduling for workloads. Also increasing overall performance by reducing pod scheduling churn and improvements to enhance autoscaling. Also added were container runtime or container startup time improvements during mounts, as well as improvements to handling stateful workloads by restricting volume write access to a single pod. Now, those are just a few of the 60 enhancements, and now let's look downstream at enhancements that landed in this OpenShift release. In this latest release, OpenShift introduces 26 customer-requested product enhancements. So these 26 are the most popular ones that were able to make it into the release. Our primary focus for this release is quality, stability, scale, and security. And among the most requested enhancements for this release, well, we already heard Daniel, thank you, talk about the Azure Managed and Workload Identity. So in addition to that, the HTTP headers to HA proxy, which allows for additional protection to HTTP requests, as well as GCP tags. So now you can, the labels and tags can be used for categorizing, organizing, and managing your resources. So further enhancements to your multi-cloud workloads. Now, passing this on to you, Ju.
Thank you, Karina. Next slide, please. Let's talk about Azure identities. For self-managed OpenShift clusters on Azure, you can now create and manage OpenShift clusters with temporary limited privilege credentials. You can use Azure Managed Identities for Azure resources for authentication in conjunction with Active Directory workload identities to securely access Azure cloud resources. We want to make it easy for you to run operators on Azure using access controls with temporary limited privilege credentials. This feature has been highly requested by customers looking to improve their security posture who want to remove their reliance on using Azure Service Principal to install clusters in Azure. In 4.14, this is focused on cluster deployments with Azure identities. And in the next release, we're going to make it easier for customers to leverage Azure identities for short-lived authentication tokens with OLM operators with well-defined patterns for increased security posture. This new functionality is available in all Azure regions where Azure Managed Identity and Azure AD Workload Identity is available, and only applies to 4.14 onwards. Note, you won't be able to migrate or upgrade from a non-Azure Identity cluster to a cluster using Azure Managed Identity and Workload Identity. Next slide, please. The previous slide. Yes. So with 4.14, we're adding support for a new platform type called external platform. The external platform builds on top of the agnostic platform, whereby cloud providers and infrastructure partners now have an easier path to integrate with OpenShift. Partners now have a way to onboard themselves with OpenShift while having full control of their own infrastructure components they wish to add to OpenShift. With the external platform, we're making it possible for partners to identify when their OpenShift deployments contain components that are replaced by their partner components. For example, in a little bit, Mac's going to talk about Oracle Cloud Infrastructure support using the external platform, and he'll cover that in more detail. Now, you can still continue to use installing a cluster on any platform, sometimes known as the agnostic method, for untested RHEL-certified environments that are virtualized, bare metal, or cloud. I'll pass you on to Anjali to talk about SCC.
Thank you so much, June. So I'm going to start highlighting, sorry for the echo if there is any, but I'm going to highlight the improvements in SCC and PSA that we bring in 4.14. So we've heard from our customers around some of the pain points they've seen with custom SCCs, specifically when the SCC is at a higher priority and is preempted by another workload. Now, this can be a workload that is a user workload or OpenShift platform operator that preempts this SCC, and this causes failures on the platform. So to prevent this, we are providing a very simple solution where you can set the required SCC annotation, and this can be set on either your deployment or on your daemon set, and this will pin the SCC to your specific workload, and you should not see failures. Some key points to note here: the SEC should already exist on the cluster, and the SEC should have the right permissions for the user and service account to use. Some quick improvements on the pod security admission control side. The default kube system namespaces are excluded from pod security. This will now run as privileged, and it helps in facilitating cloud provider integrations. Also, now users can set the pod security Kubernetes label on the namespace. This can be done if the pod security sync on the namespace is not set or is not set to true. From 4.14 onwards, we will track the ownership of these fields. So that's the summary for admission control changes coming in 4.14. Next slide, please. Okay, so we are very excited to present this feature, the Secret Store CSI driver, as tech preview to our customers. This helps auto-mount secrets from external secret storage solutions, such as Azure Key Vault or AWS Secrets Manager into your cluster. Now, this is very important for a lot of our customers that have stringent requirements to not store any of their Kubernetes secrets on the cluster. Some of the key benefits, as you can see, are highlighted here. So the Secret Store CSI driver will auto-mount external secrets. You can have one or many secrets that are mounted into ephemeral volumes. What this means is when the pod is deleted, then the secret will also be deleted. It won't persist on the cluster. The next benefit, as you can see, we are integrating with a lot of different providers. Upstream, there is support for Azure, GCP, AWS, and Vault. And the operator that we provide should work with all of these providers. One key element to note here is that the Secret Store CSI driver operator is one part of the solution. The other part is the provider that needs to come from partners. So we really encourage our partners to certify their Helm charts and operators on OpenShift so that we can give an end-to-end GA solution to our users. The next benefit, as you can see here, is that the operator is configured to auto-rotate secrets every 2 minutes. What this means is that when the secret changes on the external secrets operator side, external secret storage side, then those changes will be reflected on the cluster in 2 minutes, and you should see the updated secrets in your application. You can enable a sync of Kubernetes secrets. One thing to note here is that we discourage the sync feature, but you may have some requirements for your use cases. For example, if you want environmental variable, or you absolutely must have a Kubernetes secrets for your GitOps workflow. In that case, you can use the sync secret feature. And lastly, as already mentioned here, that the Secret Store CSI driver operator is available through OLM operation. So that's the overview on secrets management. I pass it to Duncan now.
Thanks, Anjali. Loads going on in the systems enablement side. The big ticket item for us on the ARM side of things is support for Google Cloud Platform now. And note that's just that's for both homogeneous clusters, so all ARM, or the heterogeneous clusters with multi-arc compute. So if you want to add ARM nodes in as a day 2 operation, you can do that on Google Cloud Platform as well now. So that's us. That's a tick for all the major cloud providers that have ARM support, so you can choose where you want to run and where best suits your environment. On the multi-architecture cluster side, we've also got support in there for, amongst multiple other things, for the assisted installer. So whether you're adding nodes to your first or your 50th cluster, it's going to be a much cleaner experience for you now. Of course, we can't forget our IBM Power and IBM Z offerings. For those of you who want to play in dev environments, single node OpenShift's come on board now. I think that'll be really useful there. We've got a hosted control planes tech preview that Daniel talked about, and I'm sure we'll get into more later. And of course, the advanced cluster security team. What could we do without them? They're bringing that to Power and Z as well, which is great, great news. Next slide, please. And in further good news, if you can take any more, we have extended that loveliness that is on the x86 platforms of 24-month lifecycle out onto all the architectures that we support now. So yes, ARM, yes, Power, yes, Z, all benefit from that extended lifecycle. So it's all the same across the platforms. Absolutely great news. So next, I really want to hear something about hosted control planes. So fingers crossed, Adele's going to tell us all about that. Adele, take it away.
Thank you, Duncan. You already stole my thunder. So, hey everyone, glad to be here. We're announcing this time around that GA release opens. So, what's in the bio? We're announcing the GA of the agent provider, which would allow you to deploy hosted clusters on bare metal using the agent provider. We're also announcing the GA of the OpenShift virtualization provider, which would allow you to deploy hosted clusters using OpenShift virtualization VMs, nested OpenShift. We're continuing the AWS tech review for the AWS provider. We're also introducing a couple of features that Duncan already talked about. ARM control planes and x86 node pools, flexibility plus. We're also introducing a tech review of IBM Power and Z node pools or worker nodes. So why does it matter? Why should you care? If you want to optimize your economics, increase your margins, and meet your eco-friendly goals, in other words, sustainability, then you should care. With hosted control plane, we're utilizing the concept of economies of scale. In other words, you're going to be able to rehost your control plane in a more efficient way and utilizing resource allocation better. This will give you 30% of more of infrastructure savings, up to 60% of SRE and operations savings, because you're consolidating knowledge, you're consolidating tooling, you're reducing context switching across the cluster deployment. We're also allowing for up to 60% time savings for development. If you are like me, who deploys and have to deploy an OpenShift clusters or two every day, then you're going to notice improvements in speed and productivity. You're going to be able to either provision more or the same time amount of clusters. We're also looking at 50% reduction in power and facility costs, especially on your on-prem deployment. So if you have bare metal servers laying around, usually for dedicated hosting of control planes, so if you have multiple clusters, then you don't need that much bare metal machines anymore. You're rehosting control planes in a more efficient way. Moving that to reducing. So we're solving for multi-cluster first and foremost. If you have more than 3 clusters, then you should look into this architecture to build on efficient grounds. If you want to build your cluster as a service solution on top, then aiming for speed and time to provision, especially targeting your developers, your MLOps engineers. Then you should look, and I also recommend having a look at our cluster templates operator, our community operator upstream, as a way to implement that. Streamlining role management and segmentation. So you don't have to worry now about having mixed concerns between your end users and the maintainers of the clusters. The end users are going to focus on developing value-generating workloads, and the admins and the providers are going to focus on providing SLAs reliably. So no mixed concerns. Finally, if you want to tailor your setup of your environment, so hosted control planes and HyperShift provide that maximum flexibility in your architecture, whether it's mixed arch, as we talked about, Power, Z, ARM, between your control planes and worker, or mixed providers, or consistency across providers, OpenShift virtualization, AWS, and in the future more, then you should look at this provider. I guess that's about it for hosted control planes this time. I'm going to pass the ball to Mark Quay, who will talk about OVN network enhancements.
Great, thanks, Adele. Good updates. In OpenShift 4.14, the OVN network plugin got some big enhancements. So these enhancements focused on scale and stability optimizations. In particular, OVN's internal architecture was modified to reduce operational latency, primarily for the purpose of removing scale and performance barriers of the networking control plane. So what changed? Well, the networking flow data and the database infrastructure that hosts that information is now localized on every cluster node. And this is depicted by the box on the right showing how the data plane was reformulated into 4.14 and how that data plane is now localized on every node in the cluster so that each node is now responsible for its own network. This is as opposed to the model of previous versions where there was a heavy control plane with centralized information that had to be queried by every node in the cluster for any update. Overall, the net effect is reduced operational latency. There is reduced cluster-wide traffic between the worker and control nodes. And now cluster networking scales linearly with node count to optimize larger clusters. In other words, every time you add a node to your cluster, you're adding additional networking capacity. Because network flow is localized on every node, raft leader election of control plane nodes is no longer needed, and a primary source of cluster instability was removed. Additional benefits to localized network flow data is that the effect on networking of any single node loss is limited to just that one failed node and has no bearing on the rest of the cluster's networking, making the cluster more resilient to failure scenarios. And also, because each node does not need to communicate its networking outside of itself, there is improved security. Next slide, please, where I believe Shubha will discuss a security enhancement.
Thank you, Mark. I hope you can hear me. Hi, Mark.
You can. Go ahead.
Can you hear me?
Yes, Shubha, we can hear you.
Okay. So one new feature to highlight in the compliance area, OpenShift can now comply with the DISA STIG security guidelines. DISA stands for U.S. Defense Information Systems Agency, and STIG stands for Security Technical Implementation Guideline. These controls don't just cover OpenShift, but also covers the underlying RHEL core OS. Administrators can use OpenShift operator to automatically assess Red Hat OpenShift Kubernetes resources for compliance. And with that, I will hand it off to Daniel.
Thanks, Shubha. Let me finish off the spotlight section with some good news for anyone who's running operators on top of OpenShift. We heard that it might have been difficult to actually plan ahead in terms of maintenance windows and update cycles when it comes to running clusters at scale with a lot of operators installed, because each operator sort of has its own lifecycle. Now, starting with 4.14, we radically simplify this by providing a selection of free standardized lifecycle tiers that each Red Hat operator will now choose from now on in a tier 2, and that makes it easier for you to answer the question of how often do I need to anticipate updates that need to be applied to a new major or minor version of that operator in the context of a certain cluster version. So you see the platform aligned layer where the operator's release window and lifecycle is completely aligned with this particular OpenShift release. While the operator may support other OpenShift releases, you have always one release that has the same lifecycle, so you would actually never need to anticipate updating to a new major or minor version, just applying patches. So it makes it very easy to plan ahead. In the platform agnostic tier, there are definitely more updates to be expected, but you have the selection of multiple version lines of each of those operators that are supported in parallel on a particular cluster version. So you have sort of a gliding window where you can stay probably 1 or 2 releases behind before you actually have to update. And then lastly, there's the rolling stream here, which is where we productize very fast-moving upstream projects or technology that doesn't necessarily need a particular feature from a particular OpenShift version. Those are products that have to be updated at all times to stay supported and have a single latest version that you have to update to. However, these are then supported on all OpenShift versions that are out there. And in general, we guarantee that for every supported OpenShift version, there is at least a version of every Red Hat operator supported at all times. So we are not going to force you to upgrade in order to continue to use a productized operator. With 4.14, we are also launching a consolidated new lifecycle support policy page that has all the Red Hat operators on one page, including their version history, their compatibility information with each OpenShift release, and their expected update cadence to make that planning much easier. And with that, I'm going to hand over to Ali, who's going to walk us through what's new in OpenShift console.
Hey folks, Ollie Mobram here. I am very excited to share with you what we've done in 4.14. For this really focus on two areas. The first area is dynamic plugins. So just a quick recap of what dynamic plugins are. Dynamic plugins are a framework that allow customers and partners to come and build custom experiences on top of the OpenShift console. Super powerful. In fact, it's what our own layer products and our own Red Hat software use with the OpenShift console. So most demanded things we was the ability to come and create custom dashboards. So we've added the query browser extension point to be able to come in and update the cluster overview dashboard, or to be able to create your own standalone dashboard if that's what your needs dictate. In addition to that, we've added the ability to create annotation modals, delete modal, labels modal much easier. We added a couple of helper functions to come and set active namespace and also to be able to easily add custom error pages. Finally, the last thing we did was we updated our dynamic demo plugin, our examples, our plugin templates to showcase and give a lot of examples on how to take advantage of these new extension points. Finally, I want to mention, if you haven't had a chance, go check out either Portworx or Dell Apex. Both have built some robust dynamic plugin integrations out there. So check that out. You can see the power of dynamic plugins in real life from some of our partners. All right, next slide, please. So the next area of focus for us for the console is the console RFPs. These are, again, direct customer requests. Here at Red Hat, we take customer feedback very, very seriously. I always leave bandwidth for the team to come and address these type of features. So I'm not going to go through each one of these. I will talk about the last one, which is a very highly demanded one, which is the ability to put up a notification banner during upgrades. This is to inform all non-admins that a cluster upgrade is occurring. We got tons and tons of requests for this, so we're very excited to bring this and a slew of other customer requests this release. So that's it for me. If anybody has any feedback for OpenShift console, please feel free to reach out to me, Ollie Mobram. Next slide, please. Thanks, y'all. Bye.
Thanks, Ollie. Developer tools. We only get one slide as usual, and I'm thankful for that, but that also means that I can focus on just the highlights today and don't bore you. We will be publishing a separate complete deck of what's new in developer tools coming out the next couple of weeks, so feel free to check back into developers.redhat.com. Make sure you're signed up to the newsletter. That's worth it. Every time we'll send out one. Developer perspective in OpenShift console, got a ton of new quick starts to guide you along all the new updates for developer tools. I also want to call out Podman Desktop. So podman-desktop.io is your place to go for all kinds of container and Kubernetes things on the local desktop if you are looking for a UI that helps you build your containers and push them out to OpenShift. I also want to mention new integrations for the OpenShift IDE. We now support Helm charts integrated in VS Code, and we also have OpenShift serverless integrated. The last thing that I cannot go without is the Red Hat Developer Hub. We're in tech preview 0.2. Go to red.ht/RHDH and sign up by sending an email with your KeyIO ID, and we'll give you access so you can start playing around with the productized version of Backstage. Comes with a ton of plugins included and helps you get your journey started. So thanks a lot for your patience with me and the developer tools. Over to James.
All right, thank you, Marcus. Hello, everyone. James Faulkner here. So I'm going to talk a bit about the runtime support in OpenShift. Now, OpenShift supports a very wide range of runtimes, especially great support, as you saw on Marcus' previous slide, with Java and Quarkus. So I want to talk about the new release of Quarkus, Quarkus 3. So several new features here. Primarily, I picked out the ones that I think will be of most interest. The first one is a new dev UI. This is the UI that developers use when building applications. It adds quite a bit of new extensibility capabilities, much easier to integrate using things like Qt templates or even Vaadin components. improved metrics tracking, endpoint management, so you can take inventory of the endpoints that your application exposes and even get scores as far as performance and potential improvements you can make there. So lots of new coolness in the UI. Also in the runtime, upgrades to major dependencies, in particular, new support and integration with Hibernate 6, bringing a ton of new performance improvements, things like query highlighting, mapping improvements, making JSON sort of a first-class type, as opposed to requiring a separate JSON support library to bring in. You want to say store JSON elements in your database. We also now support Redis as a Quarkus cache extension out of the box, so that's fantastic if you're using Redis there. We also have a dev service for Redis, which was introduced in the previous version. As far as native builds, this is building a native executable, making Quarkus really start up fast and take very little memory. New version of GraalVM and Mandrill brings additional performance capabilities, new experimental debug options, and JFR integration. So if you're using a Java flight recorder to profile your applications, it now records those events that happen in the runtime that can be exposed through the JFR and mission control tooling. On the observability side, we now have we've fully adopted OpenTelemetry. It's auto-configured for you now, so you don't have to go through a lot of acrobatics to get OpenTelemetry up and running. We include the exporter by default, so you don't have to do anything there. So you just kind of add a single configuration element, and now you suddenly have fantastic OpenTelemetry support in your application. On the security front, we've added new front channel logout for OpenID Connect, and we've also added custom token verification, which is really useful for integrating with other OpenID Connect providers out there, say Azure or AWS, where they kind of have different ways of expressing group ownership or other kinds of things in the JSON web tokens that get passed back and forth. And so you can customize that to integrate with your applications, no matter how those are expressed across different cloud providers. You can also dynamically now specify the roles allowed to access a particular API. Prior to this, you had to hard code it. So you can now do this through dynamic configuration. Quarkus 3 also brings support for MicroProfile 6, which does also bring in OpenTelemetry as a new capability in MicroProfile 6, as well as improvements in OpenAPI and support for JSON Web Token improvements there. And finally, in the tooling space, we've added a new dev service in Quarkus 3, a Kubernetes dev service. This will essentially spin up a small Kubernetes server for you, an API server or a small cluster, allowing you to code against that in your applications without you having to know and care about actually instantiating Kubernetes itself. So very easy for developers to get along with Kubernetes before they deploy to production. Lots of new capabilities in the Quarkus CLI as well. First and foremost is now the CLI is now extensible for additional plugins. We've used this feature ourselves to implement new capabilities that you see below. For example, Quarkus Deploy really simplifies how you deploy applications to OpenShift. Prior to this, you had to specify 5 or 6 different configuration elements to get an application deployed to OpenShift. Now you can do it on the command line with a very simple Quarkus Deploy command. Similarly, Quarkus Image also brings new capabilities and flexibilities and ease of creating and pushing images out to registries. And then finally, Quarkus Update, a really important one here for updating from prior versions of Quarkus. It's going to handle a lot of the heavy lifting of moving from, say, Quarkus 2.13, the prior version, to Quarkus 3.2, using open rewrite recipes to rewrite most of the typical stuff, dependencies, version strings, and other components of your application. It won't 100% always update everything depending on the complexity of your application, but it will do the most tedious and boring stuff that you don't want to have to deal with. And then lastly, additional Azure functions improvements with new bindings, new integration with the Microsoft Azure SPI to make it very simple to create and deploy Quarkus applications as Azure functions on the platform. So that's it for Quarkus. And then I get one more slide here to talk about application modernization in general. As you know, we have fantastic support for lots of languages, including Java. We have lots of users of OpenShift running Java workloads on there. We have lots of users running older versions of things, Java frameworks and app servers, and they're interested in moving those applications. For large-scale deployments and large-scale migrations, we have migration tooling across a number of different capabilities in OpenShift. First one is Migration Toolkit for Applications. The new version 6.2 now has the new integration with Jira so that you can track your large-scale application migrations in both Migration Toolkit as well as in Jira, both ways, so that you can continue to use additional tooling you may have already in place with Jira while still monitoring the status of a migration from the Migration Toolkit. We've also introduced a new idea called migration waves, and this is essentially a way to group applications into business functions so that you can treat them as a group as they move through their migration phases. That also applies to the Jira integration as well. Then lastly, monitoring integration. So we now expose Prometheus metrics, not just the boring and simple stuff, but also like migration application data as well. So you can easily set up dashboards in OpenShift metrics and monitoring to monitor the status of the migrations, the applications, which ones have been assessed, which ones have not, things like that. So kind of a higher level set of metrics for your migration applications. That depends on the migration toolkit for Runtimes, which has also been updated to version 1.2. This is the kind of the core analysis piece that looks at source code, makes recommendations. We now have added support for Java 17, both for running the toolkit as well as for applications based on Java 17 for analyzing and decompiling them. We've also updated the operator. So we have an MTR operator, which is now based on Quarkus itself and uses the Quarkus operator SDK to do that. So if you're a Quarkus developer, you're looking to build operators for your applications, we have an SDK for that. And then lastly, and probably most importantly, the new rule sets. And so this is the meat of what this tool does. It analyzes the source code, makes recommendations of what to change to migrate from one thing to another. Those one thing to another's are called sources and targets. So we've added new rule sets and targets, including OpenJDK 21, support for Tomcat 10 through JBoss Web Server 6, support for Camel 3 to Camel 4, as well as support for JBoss EAP 8, which is expected to GA later this quarter. And then lastly, if you're looking to move your applications and refactor them from, say, Jakarta EE to Quarkus, we also have a new rule set for that. So a very powerful set of rules for migrating applications to a more modern runtime that's supported in OpenShift 4.14. So that's it for me. I will pass it to Gustav.
Thank you. So in this release, Pipeline 1.12 is based on Tekton 0.50 upstream, and now Tekton Chain is GA. Tekton Result is released as tech preview, which helps users to give CI/CD workflow history and separate out long-term result storage away from the pipeline controller. You can bring in your own external Postgres database for storing records and external storage like GCS, S3 for storing logs and events. Pipeline Scale is another feature that allows you to expand a custom parameter within your pipeline run. You can also extend the scope of the GitHub token to repo or global level and set policies that allow certain actions only to members of a team specifically. Finally, the operator now allows you to configure the default SCC for the pods created for pipeline runs and task runs. SCC can be set separately for different namespace and also configure the least restrictive SCC for any namespace. Next, I'll hand it over to Aubrey for GitOps.
For anyone unfamiliar with OpenShift GitOps, it's one of the layered products included within OpenShift. It enables deployments of clusters, configuration, and applications from a declarative single source of truth with automated reconciliation and self-healing deployments. Version 1.10 of OpenShift GitOps is available with OpenShift 4.14 and includes our upstream Argo CD version 2.8. Some highlights of this release include, for our OpenShift admins managing their Argo CD instances, we've got 3 new dashboards available in the admin console. An overview of all your instances on the cluster, a detailed view covering each of the OpenShift GitOps components, and metrics around the gRPC service and activity between components. One of the major problems our enterprise customers have run into has been scaling up their GitOps usage. To further automate this, we've added a new option to enable dynamic scaling of application controller replicas, and there's a new configuration item to ignore frequently updated resources that may not be directly managed by Argo, so that they don't end up filling your logs. For more information about the features we've mentioned, please see the release notes on OpenShift GitOps version 1.10. Nina, let's talk serverless.
Thank you, Aubrey. OpenShift Serverless is based on open source project Knative. And simply put, Knative is a technology that streamlines and enhances the way that applications run on Kubernetes. For our updates, we have upgraded to Knative 1.8 in our latest OpenShift Serverless. Serverless Functions is now available on IBM ZN Power using S2I Builder. Serverless functions increase your developer velocity dramatically as it provides templates for jump-starting your app and even does container creation for you. Pipeline as a code for serverless functions as a tech preview feature. This integration can improve the automation and reproducibility for your functions. Serverless can now be installed on hosted control planes, and we already heard from Ad earlier on the why of hosted control planes. We have added more configuration options for net couriers such as burst and QPS for performance gains, and multi-container support is now GA for deploying multi-container pod through a single Knative service. There is a tech preview of Event Mesh with integration with Service Mesh for multi-tenancy and implementing security through Service Mesh, and we are looking for active feedback. We have also released the tech preview of serverless logic with this release that offers workflow capabilities for managing failures, retries, parallelizations, and service integrations. Thank you, and now I will pass it on to Jamie for Service Mesh.
Thanks, Dana. So recall that Service Mesh helps you create secure, reliable microservices with automated NTLS, zero trust policies, and visibility with metrics and traces. Following 2.4, we released an update that includes a gRPC extension for external authorization, allowing users to delegate auth decisions to an external system based on gRPC in addition to HTTP. Also, Service Mesh is now available for tech preview on ARM clusters. We plan to make this GA in 2.5. Service Mesh 2.5 is coming later this year. It will update Istio to 1.18 and Galley to 1.7.3. While much of the community's focus is on ambient mesh, which we plan to bring to customers next year, this release will include dev preview support for dual stack. This is very much a work in progress feature upstream, and we don't have a timeline for GA. We also released the Sail operator and OpenShift's Operator Hub. This is a preview of Service Mesh 3, which will accelerate our alignment with upstream Istio. We plan to make this generally available next year, and for more information, you should really read the blog post, a new operator on Istio, on OpenShift. I'll now hand off to Matt to talk about installer flexibility.
Amazing, thank you, Jamie. So let's talk about installer flexibility. In OpenShift 4.14, we keep the same for use case driven installation experience that targets different levels of control automation. And these are full stack automation where the installer provisions all the areas and controls all the areas of the installation, the infrastructure provisioning, pre-existing infrastructure deployments where you are responsible of provisioning and managing your own infrastructure, where to deploy OpenShift, interactive, which is a connected experience with assisted installer, where you create your cluster through a hosted web experience, and local and disconnected experience with agent-based installer, which makes very easy deploying OpenShift in a network restricted or air-gapped environment. In OpenShift 4.14, we are extending the supported providers with a new one addition, Oracle Cloud, and I will explain a bit more details about that later. Next slide, please. So with OpenShift 4.14, we are adding a set of new features specifically for users running OpenShift on public clouds. If you are deploying OpenShift on AWS, you will be able to use an existing Route 53 DNS zone when installing a cluster into Azure VPC, and you will be also be able to attach existing security groups to the control plane and compute nodes at install time as well. If you are deploying OpenShift on Azure, we have now documented and supported disconnected deployments for both Azure and Azure Stack Hub. We are also graduating custom tags in Azure to be general available. We are adding support to NAT gateways as technology preview. And finally, we are making the source of Arcos boot image customizable by the user. If you are deploying OpenShift on Google Cloud, we are also making the source of the Arcos boot image customizable by the user, as well as adding technology preview support to user-defined tags at install time. Next slide, please. Thanks, Daniel. So, as I mentioned before, OpenShift on Oracle Cloud Infrastructure. So we are really excited to announce support for this new provider, and starting with OpenShift 4.14, Oracle Cloud Infrastructure or OCI is available as a tech preview, and you can try OpenShift on this new provider via the assisted installer or the agent-based installer, depending on your use case. OpenShift on OCI deployment is using the new configuration we are introducing for OpenShift called External Platform that you mentioned at the beginning of this presentation. And as you explained already, this allows deep infrastructure customization. Specifically, the external platform provide partners such as Oracle the opportunity to run their own components for infrastructure management. With OpenShift on OCI, the partner provides integrations. In this release, the integration includes Oracle Cloud Control Manager, or CCM, and Oracle Container Storage Interface, or CSI. The Oracle CCM provides infrastructure awareness for the platform, and Oracle CSI enables dynamic persistent storage provisioning from OCI. When deploying OpenShift on OCI, only RHEL-certified OCI shapes, this is the same as instant types of other clouds, can be used for this purpose. And with this new provider, you will bring your own OpenShift subscription to deploy OpenShift on OCI. So if you want to try it, reach out to us, and as this is only available as a preview by request. And now I'm handing over to you to talk about vSphere and other new features.
Thanks, Mac. So there are a lot of new features being introduced on the vSphere side, but I'm going to touch upon some of the highlights. One of them is around adding support for static IPs for vSphere nodes. This is in tech preview. You'll also now be able to use vSphere OVA templates to deploy archives on vSphere VMs directly from vCenter, and that's also GA. And then also part of it is that Oracle Cloud VMware Solution is part of the VMware Cloud Verified Provider Program, and it's been supported since 4.12. And lastly, the other highlight to mention is that there is an automatic vSphere CSI migration that's enabled by default with 4.14, and we'll cover that in more detail in the storage section. Next slide, please. On the agent-based installer, now we're happy to say you can use agent-based installer to install on any platform-agnostic clusters across any topology, whether it's bare metal, virtualization, or cloud environments, just like you can with UPI. We also have added the ability to specify disk encryption and disk partitioning at install time. You can also start to create images necessary for PXE booting to automate your provisioning over networks across your PXE environment. And as mentioned by Mac earlier, you can also use this installer for standing up your OpenShift clusters on Oracle Cloud for disconnected deployments. Next slide. For Nutanix, a couple things to note is we're now reducing the set of permissions needed, and so you'll have more granular privilege set to define. We also have added support for being able to assign egress IP addresses to projects. We've added support for control plane machine sets to automate control plane management. And then if you're looking to actually deploy clusters using a UI, you can now do so through Red Hat Advanced Cluster Management 2.9 in addition to the CLI. And lastly, we've also added 3-node cluster support. Next slide. On the bare metal side, also with Red Hat Advanced Cluster Management, you can now deploy onto on-premises bare metal cluster with RHACM running in cloud, and that includes AWS, Azure, and Google Cloud. And next slide, please. So we're continuing to make it easier for you to customize your OpenShift installation experience. With 4.14, we've expanded on the optional cluster capabilities. So you can choose to include or exclude certain capabilities from your deployment. And so now we're happy to add that you can disable the machine API operator, the cluster autoscaler operator, the cluster control plane machine set operator, and the build capability, which affects your build and build config during installation. And so these are in addition to 8 other capabilities today. And just note, if you do exclude any of these capabilities during installation, you can enable them later after the cluster is installed. And I'll hand you over to Subin to talk about Cloud Controller Manager and Cluster API.
Thanks, Jude. In 4.14, we have G8 out-of-tray Cloud Controller Manager for AWS and Azure platform. We did this because in upstream Kubernetes, the providers have to move from in-tray to out-of-tray. Even new providers have to support this model. There's no impact of this to the users. The out-of-tray CCM implementation is backward compatible and does not impact OpenShift. I'm also excited to share some news about Cluster API. We are gradually replacing Machine API with Cluster API. Note, we have done a tech preview of AWS and GCP Cluster API, but from 4.15 onwards, we will be doing supporting Cluster API for more platforms like Azure, vSphere, possibly OpenStack. This benefits our users because upstream CAPI has improved machine management features, and this can benefit users across all providers. Over to Jamie.
Hey, thank you. So I'm giving a couple of updates on OpenStack. First of all, we have updates for OpenShift on OpenStack. The masternode root volume types, this was a big request from our customers who are running multiple clusters and need good performance for both IOPS and latency. So we have some improvements there. For our external load balancing with IPI, we have now the ability to use external VIPs. So if you want to use F5 Big IP, which is very common for enterprise customers, you can now use that with the same ease that you experience with IPI. And masternode deployment via machine sets. We're improving the UX by offering an automated and a more predictable way to scale and recover those masternodes. Next slide, please. We're also happy to introduce the RHO-SSO, Red Hat OpenStack services on OpenShift. This is now available for dev preview. We're encouraging all customers and partners who are willing to test the dev preview to come and try this new improved OpenStack architecture. We have a diagram here for high-level understanding of what OpenStack on top of OpenShift will look like. OpenShift will be hosting the control plane and pods and also governing the deployment and the lifecycle via operators. An important distinction here is that the control plane the data plane for OpenStack is going to be separate from the hosted OCP cluster for a few reasons. For OpenStack, customers are accustomed to a long product support lifecycle, and we want to continue to provide this. We want to be able to have a minimal impact to running the workloads in case of an OpenShift update. And also, we want to have customers be able to adopt this new architecture without having to migrate or conflict with their running workloads. So please, feel free to give this a try. And I'm going to hand over to Mark Russell for CoreOS.
All right. Hi, folks. A few notes on real CoreOS and the machine config operator, trying to make your jobs easier. So top one here is that MCO managed certificates are no longer handled by machine config application. Why does that matter? No more issues with certificate rotation that are the certificates that MCO manages and pausing your pools. They will be rotated regardless of the state. Also in MCO, new Prometheus per pool metrics for a variety of things. If you want to keep track of the machine count, which machines are ready, how many are updating, how many might be degraded, you'll now be able to query Prometheus for those stats. For customers who use network-bound disk encryption with Tang, offline provisioning is now available. Now it's not necessary that all or even any of the Tang servers are online during your node or cluster bootstrap. Lastly, Libre Swan IPsec package is now available as a CoreOS extension. Next slide. A big CoreOS layering update for you. Layering is marching forward, bringing our vision of using one language to manage your applications and operating systems. 4.13 brought the GA of off-cluster builds, and now we're happy to bring the dev preview of on-cluster builds in 4.14. So now instead of using your favorite build tool, which I'm sure is Podman, in a separate build environment to customize your CoreOS images, we're going to apply your Docker files to the cluster database and let OpenShift take care of the rest. With automated builds enabled, the new MachineOS builder component will rebuild your image when you click upgrade in the console or use OCADM upgrade at the command line. The builder will pull the correct version of RCOS that matches the target release of OCP you're upgrading into, run the build with your customizations, and roll out the completed images to the cluster pools that you're targeting. Look for an upcoming blog post that will get you started with the MachineOS builder. Up next, control plane updates with Gaurav.
Thank you, Mark. So with 4.14, we are making Secrets v2 as default, so it will come out of the box, and it will make your OpenShift more stable, like it will improve your ohm kills. Next slide. So sometimes what's happened is if a customer has even though they have a lot of CPU and memory in a node, sometimes the scheduler is not able to schedule pod on those nodes, and people are wondering why is that. So we are including some preloaded dashboard and matrix. By looking at those things, you can figure out why is that happening. Next slide. We are deprecating deployment configs to deployment. Important thing is deprecation doesn't mean removal. So when you use deployment configs, you'll get a warning message saying that please use deployments. Next slide. We are removing limits in descheduler, so it will prevent the descheduler getting ohm kill. What happens is when descheduler is working hard on a lot of pods, it goes out of memory and get ohm kill. And by removing the limits, now you can easily use it on a big cluster with a lot of pods. Next slide. Maximum unavailable stateful set. This will allow user to specify the maximum number of pods that can be unscheduled or that can be unavailable during an upgrade. And this feature is tech preview with 4.14. Next, Anjali.
Thank you so much, Gaurav. So we've already talked about the PSA enhancements in a couple slides before. I wanted to recap a couple more features from the authentication team that help improve customer experience and also improve secure logging to the clusters. So the first feature I want to highlight here is the secure OC login feature. So during an OC login with a token, you typically tend to do the OC login -token command and paste the token directly, which is very insecure, and it has been flagged by many compliance teams on the customer side because the token is logged and is searchable by any sysadmin. So with this release, we provide OC login -web option. So what this will do is it will start a web browser, and you can have your users log into the IDP. Once the login is successful, the user can use OC commands for any of accessing OpenShift APIs further. The next enhancement that I want to highlight is the auth operator proxy checks. So in this, we are optimizing the number of checks that we are doing once the OpenShift auth operator is behind a proxy. This is required by some customers because they are seeing a lot more traffic to the proxy, and that has been flagged by their compliance team. So now we provide checks once per hour. Earlier it was in minutes. So this will make it more efficient and you'll see less traffic. That's all I had from the auth team. I pass on to Deepti for networking updates.
Thanks, Anjali. Now let's run through some of the networking updates we have for 4.15. First up, OVN Kubernetes as a secondary interface is now generally available. Now, this allows users to use OVN-rich capabilities like fine-grained network policies or overlay networks, enhancing the network options available for your workloads, accommodating diverse use cases. Next up, network policies are application-centric, right? It allows you to specify a pod what it can communicate to and what not. And this is created for the developers to secure their application. Now, if I'm a cluster admin and I want specific network restrictions across multiple tenants, or I want to enforce a non-overridable policy that all the tenants need to adhere to because I need to secure my network traffic, this is not possible with it. Introducing admin network policy, which is tech preview for 4.14. It's a comprehensive cluster-wide networking solution that will complement and coexist with network policy, and this is implemented in OVN Kubernetes. Next slide, please. Internet Protocol Security, the IPsec, is a set of protocols that secure your communication over network. And now as a cluster admin, I can encrypt my east-west pod-to-pod between nodes, as well as my external traffic between an OCP cluster and an external provider. And IPsec helps maintain security and privacy of sensitive information. This is, again, tech preview. We look forward to GAing it very soon. Support for multiple external gateways in OVN Kubernetes, right? What we have done this is migrate from an annotation-based implementation to a custom source along with its own controller. And now as an OpenShift user, I can configure my namespace with multiple external gateways using the CR. So my workload deployment and my gateway information are no longer bundled together. And one can also use RBAC for final access. Next slide, please. With internet globally expanding with such rapid rate, IPv6 provides a future-proof mechanism, and we're working to evolve our platform to support more connected world with dual stack support for OpenShift deployments in vSphere and whereabouts IPAM CNI. Dynamic secondary attachments enable pods to have multiple network interfaces, each serving its own distinct purpose, and we achieve this through multi-CNI, and we are leveraging 4.0 in this release and its thick plugin architecture. This offers better observability via metrics and login and help build resilient, high-performance application within the ecosystem. Many on-prem production deployments use multi-NICs, right? This is for increased bandwidth, redundancy, network segregation, etc. And given that OpenShift SDN and OVN Kubernetes are two different networking solutions on OpenShift cluster, they help, and migrating between these two environments is very crucial for adapting to changing requirements, preferences, without being constrained by the choice of your networking solution. Finally, egress IP multi-NIC support is bringing where we actually associate an egress IP configuration with a non-NIC in a multi-NIC support in OpenShift. And this capability is very, very important in environments where outbound traffic needs to be managed in a manner that according to the organization's special needs or objectives. Next slide, please. In this release, we've also upgraded our HA proxy router to version 2.6, along with new features, bug fixes, security feature updates. This bump ultimately benefits both administrators and end users to provide a seamless and responsive application experience. We know that we now have this capability of dynamically appending extra HTTP headers to your traffic in HA proxy without making any manual changes underlying your configuration file. And this is basically for enhancing your security and compliance. And this is a very, very powerful tool for administrators to fine-tune their setups so that their web applications are more secure and very easily maintainable. The ingress node firewall, right, which is responsible for filtering incoming network traffic to the cluster nodes in a stateless fashion, is now generally available. This leverages eBPF technology to provide a robust and first-in-line defense against any external threats in your cluster. And finally, we have the NM state or the network manager operator that automates enforcement, all kind of network configuration policies. And now you can access this via GUI, and this helps administrators manage all their network infrastructure very efficiently. Next slide, please. Finally, we have network observability operator version 1.4 release. Now with this release, we have providing a lot of information that can help and diagnose and debug your packet drops, DNS issues, latency issues. You can also have the ability to observe your secondary interfaces with Multis, SRIV devices, or net device mode. And more importantly, you don't need Loki. There is no dependency on Loki anymore. And if you want to export your flows to a Kafka or an IPFix, you can do so seamlessly. Do check out the blog that comes out with a lot more details. Thank you for all the, this was the networking updates. Over to Shubha for security updates.
Thank you, Deepti. Let's talk about what's new in Red Hat Advanced Cluster Security for Kubernetes. At Red Hat Summit this year, we launched ACS Cloud Service. Now, I'm very happy to report that we have a no obligation 60-day free trial available for ACS CS. So if you are looking to validate ACS Cloud Service as a Kubernetes security solution for your environments, this is the way to go. It's really easy to get started. Just scan the QR code and it will take you right to the page where you can start your trial. Next slide, please. Let's also take a look at what are some of the new features and enhancements we have made to ACS as a product in 3 core areas, starting with vulnerability management. Next slide, please. So a lot of our OpenShift customers deploy OpenShift in disconnected or air-gapped environments and set up mirror registries. Now, ACS can read the mirror setup from OpenShift and can scan the images stored in registry mirrors for vulnerabilities and report on them. We built this feature on top of an existing functionality within ACS called delegated scanning. What delegated scanning let ACS do is leverage already deployed services within a secured cluster like Scanner Slim and Scanner DB Slim for scanning images. Next slide, please. As you know, vulnerability management is not a one and done process. It's a continuous process and a very critical one from the DevSecOps perspective. Keeping that in mind, we have launched Vulnerability Management 2.0 initiative to help our customers easily manage the vulnerabilities detected in their environments and remediate them. There are 2 features we have launched under VM 2.0 in technology preview. The first one being workload CVEs. It offers purpose-built workflows to get users to accurate and actionable CVE data in just few clicks. The second one being the vulnerability reporting. So we have migrated existing vulnerability reporting functionality from VM 1.0 to VM 2.0, and we have also added one new feature which allows users to generate CVE reports on demand and download them in CSV format to their local machines. So it's easy for them to share them with the auditors or internal stakeholders who are triaging these CVEs. Next slide, please. Now switching gears to network security. As you know, ACS offers generating network policies and simulating them. We have enhanced this feature, so now users have a tighter control over which Kubernetes objects they want to select and generate the network policy for. The second enhancement is now you can actually compare the ACS generated network policy with that of the actively applied network policy to those objects in your environment. Next slide, please. We have also now added listening endpoints information within ACS GUI. Previously, it was only available through ACS APIs. It makes it easier for auditing, as well as it lists all the processes that are running in your environment and the ports that they are listening on, which is very crucial to know from network security perspective. Next slide, please. Now let's talk about shift-left approach to security and what we have done with regards to network policy. So previously, we empowered the developer personas in the ACS customer environments with a CLI tool called Rockscuttle Netpool Generate. We have added 2 options to that tool, Rockscuttle Netpool Connectivity Map and Rockscuttle Netpool Connectivity Diff. With Netpool Connectivity Map, if you have already generated that network policy at build time, you can actually visualize the impact of that network policy in either text format or in dot format, which is compatible with VS Code. As a developer, if you have 2 different branches of the same project and you have added additional workloads, we also now let you compare the network policies for those 2 branches with each other to see the difference between those 2 policies. Next slide, please. The last core area for ACS that I want to cover, we have added a new feature, is authentication and authorization. So ACS has always supported scoped access control. Now we have made it easier to configure and manage by making it configurable in a declarative format. So that way, you can store your access controls in a Git repo as code. It's easy to audit, and also they can be reapplied if you have multiple ACS environments, and hope you can take advantage of that. And with that, I will hand it off to Daniel to cover management. Thank you. Sorry, Brad.
Yep. Hello. Thanks, Shubha. Greetings, OpenShift Container Platform world. Due to a jam-packed presentation we've already heard, I'm going to cover some of the highlights, but please do refer to the deck and recording. Will be made available after this presentation online. And if you have any questions, just open an ACM support case for any follow-up needs. We'd love to hear your feedback on ACM 2.9, as well help us shape ACM 2.10 moving forward. Next slide, please. And here I'd like to highlight the Nutanix support. We mentioned it earlier in the installer flexibility. Rackham will expose that. And we have another feature I'd like to call out where we have the disk wiping for zero-touch provisioning. And more to come there on the scale slides. Next slide, please. Yep, here we're going to cover the fleet management. And this is, again, how we extend scale with our global hub operator. And you'll see we have two elements to that. And the central view to see your aggregated policy compliance and trends across all of their regions. That's really powerful. And then an inventory of managed hubs and managed clusters for easy understanding of fleet topology. As well, we'll be sending alerts when anomalous policy behavior is found. The field teams and consultants have already started working on Ansible event-driven solutions based on policy lifecycle events. Next slide, please. Here we have governance, the governance pillar of ACM, and the framework is continuously evolving to keep up with the growing Kubernetes policy landscape. You'll see we have inform-only remediation, we have gatekeeper operator uplift, and policy view design customization. These are some of the key things I wanted to cover. Next slide, please. Here's the application lifecycle pillar for Rackham, and here we have an integration with the OpenShift GitOps offering. We keep building upon that and getting stronger. With this release, we're now able to display Argo CD multi-source applications in the application topology. This is a common pattern used in the GitOps space where a single application pulls from multiple different locations. So being able to visualize that is going to really help your admins. This is a technology preview feature right now. Please do, again, open an ACM support case and help us shape that if you're interested in that technology preview offering. And still in the GitOps space, we're happy to announce integration has become even more hardened with service accounts responsible for deploying Argo CD artifacts. You can now have custom permissions assigned and not just the default cluster admin rights. Next slide, please. And here we have the management at scale. This is exciting. We're always evolving the scale, extending your management scale, and we lean heavily on different operators, including the topology-aware lifecycle manager. And one of the key features of that is the cluster group upgrade timing, and that helps with selective policy enforcements. And we're able to manage up to over 3,000 single node OpenShifts with the DU, distributed unit profile. That's a CNF workload, a containerized network function. We also have some mixed fleet numbers in there, and these are again based in Red Hat Labs. And so you'll see use case for retail where we have cluster deployments with compact deployment model, and then we also have some standard ones in there. And we would invite you to follow us on the November 29th Ask an OpenShift Admin series. We'll be in there with the ACM team going over some of these features as well. We've announced a hub capacity planning tool. So we're going to do some deep dives into those. Again, that's November 29th. That's a follow-on to a most recent Ask the OpenShift Admin where the Quay burner was featured. So that's exciting for us to share with you. Next slide, please. We're going to cover some business continuity here. We have our OpenShift Data Foundation, regional disaster recovery. All of these will help with your business, protect your business critical workloads. With the ODF, regional disaster recovery, we utilize Submariner for the cross-cluster connectivity. And then I want to call out the asynchronous volume replication and the automated failover management. There's embedded in this slide are two videos I'd encourage you to watch, and these are how advanced cluster management can hook into Ansible automation platform. That's real powerful when you're trying to stitch together an end-to-end solution. and protecting your business critical workloads. Next slide, please. And then I'd like to hand this off to my product manager pair, Quiana Berry. Thank you.
Thank you, Brad. Well, hello, everyone. My name is Kiana. I'm a PM on Quay, and today is a great day to learn about Quay. I'm thrilled to share the updates on behalf of the Quay team on all the things we've been working on to help empower you and optimize your workflows. Overall, the Quay team is investing heavily in improving consistency with OpenShift, intuitiveness of the user interface, and expanding product functionality to better serve your needs. One way we're doing this holistically is Quay now will align with OpenShift release cadences by about 2 weeks to enable smoother integration. On a product level, by customer demand, we've listened, and we prioritize the ability to intelligently prune old artifacts with the end goal to increase your productivity while reclaiming storage space with ease. In the future, we'll add multi-policy and global configurations. On the face of the product, Quay's Pattern Flags UI will deliver consistent Red Hat look and feel while modernizing the navigation and enhancing overall intuitiveness in the UI. Users can now preview the UI today on console.redhat.com before it becomes default next year, and we definitely would love to give your feedback between that. We'll continue to roll out new UI capabilities there, so do stay tuned. And lastly, on the Red Hat Quay UI front, we'll enable enterprise workflows in the UI by delivering features like quota and super user management. Overall, users are the heart of Quay's development, and we encourage you to chime in our surveys and to get involved so that we can co-evolve a better Quay for everyone together. Thank you. I'll now hand it over to Jamie Parker from Observability.
Hey, thank you. Next slide, please. So I have some quick updates to give on all of our 5 observability pillars. Next slide, please. For data collection, for monitoring, we are adding options to specify resource limits for all components and not just. We have additional customizations for Nord exporter collectors, and we're extending the topology spread constraints to all pods. For logging 5.8, we will have Cube API audit log filtering to reduce large log sizes. And we're happy to announce that for OpenTelemetry and tracing, we have a tech preview of the OpenTelemetry operator that will enable support for OTLP metrics. Next slide, please. Storage. In monitoring, we are reducing memory sizes by changing implementation of Prometheus labels. For Loki, we have some additional features that will help for Loki usage, zone-aware replication, and then cluster restart and reliability hardening in case of node and cluster restarts. In distributed tracing, we have tempo support for Jaeger Thrift, gRPC, and Zipkin. And Tempo Gateway, we're querying the front end with authorization and authentication. Next slide, please. For data delivery and monitoring, admin users can create new alerting rules based on metrics, and we're deploying the monitoring console plugin resources via CMO. In logging, we are enabling multiple log forwarders, so users can forward logs to multiple endpoints instead of a singular endpoint. And in our OpenTelemetry operator, we're forwarding OpenTelemetry metrics outside of OpenShift via HTTPS and gRPC, and being able to convert OpenTelemetry metrics to Prometheus, adding resource detection and K8's attributes processor for enriching those metrics. Data visualization in monitoring, we can now expire silences in bulk. And we have a silences tab added to the web console in the developer perspective. In Loki, we have log-based alerts in the web console for developer perspective, and we're adding Loki stack searching across namespaces and Loki health dashboards. Next slide, please. And finally, for analytics, we have a dev preview of our correlation experience in the web console. This will link alerts to logs and logs to metrics. This is powered by Correlator, our open source project. We invite you to take a look at Correlator and then contribute to it if you're interested. And I will now hand off to Radek for Insights.
Thanks, Jamie. So Insights is a set of features that builds on top of what Jamie was talking about, our observability stack, and enhances that with our own experience with running and supporting OpenShift. We recently are adding more features that are also leveraging different machine learning techniques. And one of such features is called Insights Update Risk. This is a feature that you will find on console.redhat.com/OpenShift/Insights Advisor. And this will basically do a pre-assessment of your cluster infrastructure to highlight conditions that are potentially putting your update in risk. And we're highlighting those that you really have to pay attention to. So we highly recommend to check those before you do any kind of update on your system. The recommendations engine that we're running is continuously being enhanced with additional recommendations, again, based on our own experience. And we recently added a lot of recommendations focused on storage and network and performance. So go check those if you're using Ceph, if you're using vSphere for your storage. ACM 2.9 was already presented, and we have a new integration there that allows you to do these insights, recommendations, and remediations directly within the ACM UI. Workload recommendations are also interesting. This is a feature that we're only providing to customers of managed OpenShift today, but I highly recommend watching this feature because it allows you to look at or assess the workloads in your cluster for best practices and make sure that these workloads are not harmful to your cluster. And this feature is getting into on-prem advisor as well in a couple months. So again, something that I highly recommend. Our next service, next slide please, is called Insights Cost Management. Again, additional service that is free of charge. You can start using it immediately, and it allows you to look at reporting, cost reporting for all your workloads on the cluster. And we understand that our customers are requiring different granularity for how they want to charge their tenants, their users, for different projects running on the cluster. So we improved the granularity by additional metrics around requested, effectively used CPU, RAM, and storage. And we also allow you to distribute the overhead cost for running OpenShift as it is in between your projects. To do these changes, you have to set up a cost model within cost management, and we have revamped the setting page and moved it closer to the actual workflow in the cost management app, so we can make these changes more easily to these different cost models. And last thing, if you haven't used cost management before, the new operator actually allows you to create a default source, so you don't have to do additional settings, and you have some default configuration that you can start using immediately to see these interesting cost reports that you will find in cost management. All right, back to you, Jamie.
Okay, so I'm happy to again present on sustainability. We have already presented Kepler. This was our CNCF sandbox project that was accepted earlier this year. Kepler is a metrics exporter that uses eBPF to collect system stats and export them, so it can provide granular power consumption data for Kubernetes pods and namespaces and nodes. Next slide, please. Power monitoring is the productization of Kepler. We're releasing the developer preview next week. So power monitoring will integrate with the OpenShift console, and we already offer 2 dashboards to check this power consumption and per namespace info. And with that, I will hand it off to Peter for OpenShift virtualization.
Thanks, Jamie. So we've got a lot going on. I'm just going to hit the highlights here. You'll be able to run applications in virtual machines in ROSA and AWS in 4.14. You'll also be able to recover from large data center events like fires and floods and power failures using the MetroDR capability, which will give you near zero RPO with OpenShift Data Foundation storage and orchestrated by ACM. One of the other highlights for networking is you'll be able to dynamically hot plug NICs into and out of a virtual machine. And the migration toolkit for virtualization allows you to migrate virtual machines between different OpenShift clusters and will also allow you to do OVA import. Next slide, please. As Adele talked earlier about hosted control planes, we allow you to spin up hosted OpenShift clusters on a bare metal OpenShift cluster. A couple of benefits here, which is much better utilization of the hardware footprint, isolation for the tenant clusters, and much faster deployment. We've got it down to about a new OpenShift cluster in about 10 minutes. So if you're running OpenShift on a traditional virtualization provider today, you can actually use OpenShift hosted control planes as an alternative to quickly deploy OpenShift production clusters on OpenShift. I'm going to turn it over to Jochen to talk about, Open Sandbox. Thank you.
Thanks, Peter. And I'm happy to present some news on the OpenShift Sandbox containers, which is a kernel isolation for containerized workloads. So the most amazing thing that we can present today is that peerpods are GA now. Peerpods means the ability to spin off and run containerized workloads even in the cloud and outside of your cluster. And another important step forward is now having flexible instance sizes for the peer pods. So this no longer fixed sized VMs. We identified a pretty great use case in the CI/CD area, which we are running right now, and sharpened the product with a lot of customer feedback, which is very, very good. And second is on the confidential containers project, we now have support for encrypted containers and also secure key release for encrypted containers. Beside of all that, we are now on a project supporting sandbox containers also on IBM Z as a tech preview. Thanks for now, and handing over to the next one.
Hello. So now you can boost your AI workloads with Red Hat OpenShift on the new NVIDIA L40S GPU accelerator. So the L40S is based on the new Ada Lovelace GPU architecture and is providing impressive generative AI performance. So this GPU is versatile because it can accelerate AI-enabled application and do video processing on OpenShift. We are collaborating with NVIDIA to provide AI GPU acceleration across the hybrid cloud. So you can use GPUs on your favorite cloud providers as GCP, Azure. On AWS, the NVIDIA GPU operator is now supported on the new AWS P4DE and also the P5 instances with Hopper H100. So Marcos spoke of the Oracle Cloud infrastructure as a tech preview. Then now you can start using OCI NVIDIA A100 chips. So with compute acceleration, not yet, Red Hat OpenShift helps power a next generation of data center workloads, so you can train, inference, and run large language models for GenAI applications. Speaking now on kernel module management, so the KMM operator manages kernel modules on device plugins in OpenShift as a day 2 operator. So KMM is a quick go-to-market enabler for partner-accelerated solutions. So KMM helps enable new specialized hardware as AI accelerators. We are speaking of GPUs, so it can enable GPUs. With KMM on our partner collaboration, we have enabled the Gaudi Habana processing Unix for AI acceleration or accelerate AI application with Intel GPU Flex series. Following the 1.0 GA release, we are supporting new features as disconnected support, customizable steps for kernel module upgrades, replacement of in-box kernel modules, third-party support policy, and with a single KMM module, can now deploy multiple independent kernel modules. So the new KMM 2.0 release after OpenShift 4.14 will reduce the resource utilization and support firmware files without machine config objects. This new release is providing a better upgrade experience. I give the mic to Duncan.
Thanks, Owen. Windows containers. We're bringing online cluster-wide proxy in the next release, and who doesn't love a new cloud platform? Well, Nutanix is going to be a supported platform to run. But the one thing that I want you to take away from this slide is the storage and CSI proxy update that we're going to have in the next release. Essentially, those of you running on vSphere and Azure, the in-tree drivers are getting removed, and you're going to have to do some work as part of the upgrade. So that's going to be things like getting your own CSI driver from vendors or upstream and getting those on the nodes before you upgrade. We consider this serious enough that we're actually going to try and block upgrades on nodes that where we detect volumes, and you're going to have to actively acknowledge that you want to proceed to upgrade. So don't worry too much about it. We'll have a very well written and very well informed blog ready around launch that will take you through all the steps. We'll make sure our documentation's up to scratch, but just keep that in mind for the next upgrade. It's going to be a little bit interesting. And next, Windows containers wouldn't be what it is without the operator framework. So I think Tony's going to talk to us now.
Thank you. In this release, we are pleased to introduce the OM 1.0 Phase 1 preview. I won't go over everything here, so the most notable thing is about promoting fully declarative workflows and simplifying operator fleet management UX. The operator API streamlines the management of the installed operators by consolidating user-facing APIs into a single object, so the desired state can be easily defined and automated with GitOps. The catalog APIs provides greater visibility to all available bundle versions, including their details, channels, and update edges. ORM 1.0 also empowers admin to have more control over the target version for an operator update, which is a long-awaited customer ask. This represents just the first phase of the tech preview. We eagerly await your feedback. Please stay tuned for more to come. I'll hand it over to Greg for storage.
Hello, everyone. Thanks, Tony. Starting with CSI drivers, Google Cloud File Store is now fully supported. This allows users to provision RWX PV's file-based storage. On the Azure front, we're adding support for the NFS protocol to the Azure File CSI driver to cover FIPS and POSIX compliance use cases. Worth noting that we backported this to 4.12 and 4.13. Next on the list is the vSphere CSI migration, GA. If we can move to the next slide, I'd like to provide more details. So that migration is a bit different than what we had in the past for other providers. The thing is, we have known bugs in vSphere itself that can impact CSI migration. And in 4.14, we are enabling a migration by default. Meaning that in 4.14 it will be on for all environments. The good news is VMware has recently fixed the two issues at hand. And given the nature of the bugs, we added checks in 4.12 and 4.13 that will prevent upgrade to 4.14 if OpenShift is not running on a patch vSphere version. So that doesn't apply to environments that already have CSI migration enabled or don't use in-tree PV. Same for new 4.14 clusters. But we know customers have some challenges to update vSphere. In that case, we added an option to override that requirement and proceed with the upgrade. While this is fully supported, we obviously strongly recommend customers to evaluate the risk before going that route. Next slide, please. All right, next up, a new volume access mode as tech preview that ensures that the volume is accessed by a single pod only, even if these pods run on the same node. Next slide, please. Last, ODF, as mentioned earlier, we are on a GA for regional DR. Otherwise, the NFS service has been improved with support for multiple namespaces. We also improved the automated IPv6 discovery, as well as increasing the maximum supported disk size to 16 terabytes. Last, we are introducing tech preview for non-resident storage classes backed by single replica. And that's it for storage. Handing over to Daniel.
Thanks, Greg. Because we're running out of time, let me hurry up a little bit and really focus on that major highlight. This super exciting news with 4.14 is the general availability of Red Hat Device Edge and Microshift. You can read on the slide what this is about. The major key new feature we added for GA is updatability and automatic rollback. Rollback, especially for RPMOS tree-based deployments in case the health check fails, because that is really a key feature you need to your far edge deployments to avoid bricking small edge devices like this. And with that, I hand over directly to Frank for Telco Edge update.
Thanks, Daniel. So, telco operator network is made of BGP connections, and you have clusters going up and off as we deploy new application. 5G clusters are getting out of maintenance or scaled out. Before that feature, every time a new cluster was deployed on the network, on the OpenShift side, we had to configure new static routes for each and every VLAN because the traffic is segregated to reach out for the various remote clusters. With this feature, we stretch the BGP down to the OpenShift node, so the OpenShift nodes automatically learn without any human interaction or any script by BGP natively when a remote cluster is deployed or removed, and all of the routes are automatically configured. Next slide, please. Next slide, please.
There might be a little lag. We are on pre-cache user-specified images with TLM.
Okay. Okay.
Go back one slide, please.
Yeah. Okay.
You're good, Frank. Go.
Okay, anticipating. Okay, so on the next slide. So we have a new feature that permits to have a more fine-grained NUMA scheduling. So before that feature, you always had to have memory, CPU, and network device on the same NUMA node. With this feature, you can say per network attachment definition if you need to be on the same NUMA node as your NIC. Of course, the memory and the CPU will be on the same NUMA node. And this permits for servers which have only one NIC to pack data plane pods on both NUMA node and not to waste any CPU on your server. That's all for me. Next slide is for you, Rob.
Thanks, Frank. In a previous OpenShift release, we added the ability to pre-cache OpenShift images via the topology-aware cluster manager operator prior to an OpenShift upgrade, so that the cluster has all the images for the upgrade cached locally before starting the upgrade. This feature reduced the upgrade time as the user is not waiting to download images after initiating the upgrade. We've extended this concept to CNF upgrades, where we allow the user to specify a list of images and associated tags to pre-cache prior to initiating a CNF upgrade. This ensures that all CNF images are cached locally before starting the CNF upgrade, and therefore reducing the CNF upgrade time. Next slide, please. The Telco Far Edge zero-touch provisioning process that configures a single node OpenShift instance for a DU workload makes use of a Red Hat GitOps plugin called ZTP Site Generate to configure the node. This plugin provides a single version-specific DU reference configuration. So for example, there's a 4.12 DU reference configuration in the 4.12 ZTP Site Generate plugin, and a 4.13 DU reference configuration in the 4.13 ZTP Site Generate plugin. In other words, for every OCP release, there was a corresponding ZTP Site Generate plugin used to configure the node for a DU workload. A 4.12 ZTP Site Generate plugin cannot be used to deploy a 4.13 DU configured SNO. In 4.14, ZTP Site Generate GitOps plugin can now reference the version-specific DU configuration entirely from Git instead of from the plugin. This decoupling allows a user to declare multiple versioned DU configurations in Git, one for each OCP release they wish to provision. The 4.14 plugin still contains the 4.14 DU configuration CRs, but you can now use the 4.14 plugin to deploy a 4.13 and a 4.13 and a 4.12 single node OpenShift clusters and configure them for DU workloads using this new methodology. In summary, in 4.14, with a GitOps ZTP Site Generate plugin with version N, you can use ZTP to deploy single node OpenShift clusters and configure them for DU workloads with versions N, N-1, or N-2, giving telecommunication providers much more flexibility in which OpenShift versions can be installed without having to update the GitOps plugin. Next slide, please. Last, but certainly not least, Intel's 4th generation Xeon Scalable processors, formerly known as Sapphire Rapids, have been certified with Red Hat Enterprise Linux 9 and are fully supported by Red Hat. Furthermore, Red Hat has validated this platform for RAN VDU workloads using Intel vRAN Boost for FEC offloading. Not only does this platform bring increased computing performance, but the Sapphire Rapids Edge Enhanced SKU moves forward error correction acceleration on die and removes the need for a discrete accelerator card like ACC 100. With that said, I'll hand it back to Daniel to close out our presentation.
Thank you, Rob. Thanks everybody for listening in. That's it from us for what's new in OpenShift 4.14. Remember, this is a community. Or a user of OpenShift or a partner, be sure to check out OpenShift comments where you can share your success story, learn more about your peers and what they're doing with OpenShift, and present your integration with the OpenShift platform.